Mastar türleri ve mastar seçimi. Mastarlar makine parçalarının toleranslara uygunluğunun kontrolünde kullanılır. Mastarların bazıları tek başına, bazıları da diğer ölçme ve kontrol aletleri ile birlikte kullanılır. Mastarlar ölçü aralıkları ve toleransları sabit kontrol aletleridir. Bu özellikleri nedeniyle seri imalatta sık olarak kullanılırlar. Tampon Mastar, Vida Mastarı, Çatal Mastar, Mastar, Prizmatik Mastar, Silindirik Mastar, Vida Kalemi Mastarı, Kalınlık Mastarı, Konik Mastar, Profil Mastarı. Tampon Mastar. Bu mastarlarla deliklerin imalat teknik resminde verilen toleranslar içerisinde yapılıp yapılmadığı kontrol edilir. Çeşitli çap ve boylarda ihtiyaç duyulan ve uluslararası standartlarla belirlenmiş olan ölçü aralığında yapılırlar. Mastarın bir tarafı geçer, diğer tarafı ise geçmez ölçüdedir. Çap, geçer. Tolerans, geçer yüzey. Geçmez yüzey. Geçer, kalın, geçer tolerans. Tolerans, çap, geçmez tolerans, geçmez, ince. Vida Mastarı. İç ve dış vidalar için standartlara uygun olarak üretilir ve vidaların hassas olarak kontrollerinde kullanılırlar. Hem metrik hem de inç ölçü sistemleri için standart olarak piyasada bulunabilirler. Dış vida mastarı, dış vidaların uygunluğunun kontrolünde kullanılır. Mastarın üzerinde çapı, adımı ve toleransı belirtilir. Mastar, açılan vidaya uyarsa parça uygundur. Mastar vidaya uyum sağlamaz ve geçmezse hatalı imal edilmiş demektir. İç vida mastarı, iç vidaların uygunluğunun kontrolünde kullanılırlar. Geçer. Anma çapı. Adım. Geçmez. Adım. Anma çapı. Geçer. Geçmez. Çatal Mastar. Silindirik iş parçalarının dışçap ölçü toleransının kontrolünde kullanılır. İki tarafı yarım ay formunda çelik dökümden yapılmış, her iki tarafındaki çene ağızları çok hassas ve ölçü tamlığında işlenmiştir. Çatal mastarların orta kısmına esas ölçüsü yazılır. Büyük tarafı geçer, küçük tarafı geçmez taraftır. Gövde üzerinde ana ölçü ve yanında geçme tolerans türü yazılır. Johnson, Blok, Mastarı. Dikdörtgen prizma biçiminde, çeşitli ölçü ve tamlık derecelerinde üretilmiş, yüzeyleri sertleştirilmiş ve hassas şekilde işlenmiş çelik parçalardan oluşan mastarlardır. Mastarlarının karşılıklı iki yüzeyi çok hassas olması nedeniyle, istenilen toplam ölçüyü meydana getirmek için birleştirildiklerinde, yüzeyler arasına hava girmediğinden mastarlar birbirine yapışabilmektedir.
link.
Mastarların bir yüzünde milimetre cinsinden mastar ölçüsü ve sınıfını gösteren harfler bulunur. Blok mastarları, hassasiyetlerine göre olarak gruplandırılırlar. Kullanılan blok mastarların yüzey aşınması nedeniyle zaman içerisinde hassasiyetlerinde azalma olur. Bu nedenle hassasiyeti azalan mastarlar bir alt gruba alınarak kullanılabilir. Mastar takımları parça sayısına göre değişir. Takımlar genellikle 18, 32, 47, 56, 76, 87, 103, 111 ve 128 parçalı olarak imal edilir. En küçük mastar ölçüsü 1,005 mm, en büyük ölçüsü ise 100 mm'dir. İstenilen ölçü mastarlar birbirine eklenerek elde edilir.
Precision starts here. Repeatable, accurate, traceable precision. Of the hundreds of inspection tools available to us, gauge blocks are special. Now, they don't appear to do much. They just sit there with no electronics, no gears, no moving parts at all. But this isn't a fault, it's their genius. Designed to be stacked one on top of another with high reliability and precision, they're the final say in accuracy when used to measure our parts or calibrate other inspection tools. Pick a number, any number, and we can create a stack of gauge blocks to that height in increments of just 1 micron for our metric sets, or 1/10 of a thou for our inch sets. Placed on a granite surface plate, our gauge blocks can be used as a reference to measure the height of a part or feature with incredible precision. Combined with a drop gauge, our gauge blocks can provide the absolute reference values that we need. Now, we will use gauge blocks along with a little trigonometry to produce perfect angles using sine bars or sine plates. With the right accessories, they can be used to create precision gauges for inside diameters, ID features as well, saving us the cost and lead times of custom ring gauges for every job. Gauge blocks provide that second opinion, the final verdict, when it comes time to verify all of our other adjustable measurement tools. And if you are new to machining, they can be a terrific tool to hone your measurement skills, making sure that we aren't pushing too hard or too lightly with our other hand measurement tools, like calipers. A good set of gauge blocks is what connects your shop to the rest of the world, making sure that 1 inch in California is the same as 1 inch in Ohio, making sure that we're all traceable back to the same outside sources. The gauge blocks that we use should be serialized and certified for accuracy to the ASME, DIN, and ISO standards. Building a stack of blocks is just one of those essential skills that every machinist is expected to master. Now, with a target height in mind, we will start by finding the block that can provide us with our correct least significant digit, our smallest value, that far right decimal value in our height. From there, we will work our way up in size from small to large, right to left, until we've created our desired height stack-up. We would follow this same roadmap if assembling a stack of metric blocks. Now, we don't just stack our blocks together, we actually ring them together, like ringing our hands. This creates a strong bond that holds them firmly in place. Now, this is an amazing property of physics that is worth looking up sometime. Now, these blocks stick together perfectly, just as expected. But if two blocks don't stick to each other, they might be dirty or damaged. It's that bond between the blocks that let us know that they are clean, flat, and accurate. The mere act of ringing blocks together is kind of an in-process inspection, letting us know that everything is okay. If dirty, we can clean them with rubbing alcohol or mineral spirits. Now, it's always a good idea to wear gloves of some sort when handling expensive gauge blocks. But to be honest, I don't often wear them. I'm just too busy measuring parts. But I do take very good care of my gauge blocks, and I've never had a problem because I always, every time I'm done using gauge blocks, wipe them down, cover them with a light oil, wipe that oil off, and place them back in their protective boxes after each use. While we need to respect our gauge blocks, they're not fragile. They've been hardened to 63 Rockwell or better. So you're not going to wear them out by cleaning them. Not something you have to worry about. There are 8 sets of blocks on this table, but we most likely don't need 8 sets of gauge blocks. So we've got some choices to make. These 4 are all in metric, different grades, different number of pieces per set. These 4 boxes are all in inch. So right now, for the sake of argument, let's just say that we need an inch set of gauge blocks. And then there were 4. Now, these can be split up into 2 discrete groups. There's different grades, different levels of accuracy. We have an AS1 grade and an AS0 grade. And the choice we make here is just about how much accuracy you actually need. We can expect from most gauge blocks in a set to be accurate within plus or minus 8 millionths of an inch. 8 millionths for each and every one of these gauge blocks, while a grade 0 set might be accurate within plus or minus 5 millionths of an inch. For our metric sets, which we're not looking at the moment, we might be plus or minus 0.12 micron for a grade 0 set, or plus or minus 0.2 micron for a grade 1 set. This is incredibly accurate. Now, I would use a grade AS1 if I was going to be comparatively measuring parts on the shop floor on a daily basis. If I wanted to go further than that with more accuracy, I would go with a grade 0 set that can be used to calibrate other tools. And then there were 2. Now, with these sets right here that are left, you can tell right off the bat just by looking at them that this set has more pieces in it than this set. This is an 81-piece set. This is a 36-piece set. And the crazy thing about this is that they both do the exact same thing. But this one's going to use half as many blocks to get there, which means the price, the expense for this set is going to be much cheaper. So why go with a larger set? Here, check out this side-by-side example. Both stacks are built to 3.7889 inches tall. The one on your left is from the 81-piece set, the one on your right from the 36. With more available block choices, we can typically create most stacks with only 4 blocks using the 81-piece set, while building from the smaller set offers fewer choices and might require 5, 6, or 7 blocks in many cases. Fewer blocks in our stacks means less setup time and a slightly smaller stack up error. So what does all this mean? What would I go with? Well, for an inspection room setting, I would definitely go with the higher grade and the larger set. There's going to be a small difference, very small difference in stack up error, but it's actually going to take fewer blocks to get to that stack up each time, which will save you the amount of math you're doing all day long. Larger sets, higher accuracy for your inspection rooms. Now, for my personal toolbox, I'm probably going to go with the smaller set, like this 36-piece set. I can get to the exact same numbers without a problem, and this box is going to cost me a lot less money, and it's going to take up a lot less space in my toolbox. Well, hopefully this information has made choosing which gauge blocks are best for you a little bit easier.
Prizmatik Mastar. Bu mastarlar çelik ya da çelik dökümden yapılırlar. Kontrol ve markalama işlemlerinde kullanılır. Biçimleri prizmatik olup, bütün yüzeyleri sertleştirilmiş, hassas olarak işlenmiş ve taşlanmıştır. Mikrometre, kumpas, komparatör gibi ölçü aletleri ile birlikte kullanılırlar.
Yeah, so hello, this is an angle gauge block set with 100 pieces. Yeah, most of the set is never being used. This one I can show you, for example. This one without, yeah, the other one they're all packed like this, and it looks like they were never outside of this oil paper. Yeah, this one is without oil paper, the 60 degrees. There's some grease, some dirt on it, but the condition looks fantastic. Yeah, the set I think is complete. The only thing what I discovered here that there's one piece here, and it's double, which means there's also one piece missing. To be more precise, this one and this one are the same, and the one which is not there is the one with these numbers. I can show it from close. Yeah, in here are some tools. Probably it's to combine the blocks. And here are some pins with angle. .6, 0.6. Yeah, maybe I can show all the different sizes which are available in the set. So here it starts at yeah, this is dirty and grease. 15 degree and 1 minute. 15 degree and 2 minutes. Then it goes up to 20, then it goes from 30, 40 and 50 minutes. And then it starts here with 10 degree, 11, 12. All the time with 1 degree step, it goes up. Let's see. All the way to here, the last one, 79 degree, and then it goes to 80 degree here on a square block. 81, 82, 83. So all sizes are here. Thank you for watching.
Silindirik Mastar. Bu mastarlar ile silindirik iç deliklerin ölçme ve kontrol işlemleri yapılır. Ayrıca, Kırlangıç kuyruğu ve benzeri yapıların ve açılı yüzeylerin açı ölçme işlemlerinde de kullanılırlar. Bu mastarlar da çelik veya çelik dökümden imal edilir, yüzeyleri sertleştirilir ve hassas ölçüde taşlanır. Çeşitli çap ve boylarda yapılır.
Hi everyone. Today I'd like to talk about gauge pins. Now these are used for measuring small holes as well as gauging as far as whether you are or are not in tolerance. You can also use them for setting a micrometer to make sure that it's reading correctly on the dimension that you want. Gauge pins are generally sold in sets. This one goes from 61 thousandths of an inch up to 250 thousandths of an inch by thousandths of an inch. They have a smaller set that goes from 11 thousandths up to 60 thousandths, and a larger set that goes from 251 thousandths up to half an inch. After that, most people and shops would buy gauge pins individually because the sets are prohibitively expensive. They also sell these as minus and plus sets, meaning that the pins either read minus 0.2 of a thousandth or plus 0.2 of a thousandth. I find that the minus set works better for what I do, which is mostly measuring small holes. The minus 0.2 allows me to slip it into a hole that is exactly the size of that pin. The pins are all marked with the size, so hopefully you can see this on camera, but it says right there, laser marked, that this is the 250 thousandths minus pin. Obviously, if this was the plus set, it would say 250 plus. And yes, even the 61 thousandths pin has the size marked on it, but I'm sure you're not going to be able to see that on camera. if you have a small hole like this, you can't really rely on calipers because the inside jaws on a caliper are kind of flat on the side. And I've talked about this on one of my other videos, the 4 different ways of measuring with calipers. So generally, especially on holes smaller than an inch or so, caliper measurements are incredibly unreliable when using those internal jaws, just because they tend to measure smaller than you actually have. When you're measuring a small hole with it, you would grab a pin that's roughly the right size. So I'm going to grab, this is 215. You would put that in there, and you know that's not the right size because you can wiggle it around in there. It's quite loose. So then, you know, you can go up to maybe 220. Okay, well that's closer, but it still fits in there. And then at that point, you just go with each successive pin. That one's still too loose. And then, in this case, this is the 222 pin, and that's a really snug fit. It still slips in there. And keep in mind, this is 222 minus a couple of tenths. And then the 223 pin does not fit in at all. So you know, just from that measurement, that you're somewhere between 222 and 223, which is generally close enough for most work. Another use for these would be to make sure that your micrometer reads the correct amount at the dimension that you're shooting for. So if I were shooting for 250 thousandths, I could grab my 250 thousandths pin and make sure that my micrometer reads the correct amount. There's some wear that could happen over the travel of the micrometer, so it's really good for tight tolerance work to make sure that it reads the correct amount. Now you do have to keep in mind that this is a minus pin set, so my micrometer reading should actually be 249 and 8/10, and it is right on the money. So my micrometer is good to measure for whatever 250 thousandths dimensions I might have. The name gauge pin comes from its use in what are called go, no-go gauges. And you can buy handles like this. You can see you've got a green side and a red side, and it's labeled go and no-go. This handle actually works for the entirety of the range of this set, from 61 thousandths all the way up to 250 thousandths. So in use as go, no-go gauges, let's say your hole tolerance was from 220 thousandths up to 225 thousandths. Well, you can grab your 220 pin and you can put it in the go side. This tightens up just like a drill chuck. And then grab your 225 pin and put that in the no-go spot. So in this case, we'll go back to our little hole that we had earlier. If the go side fits in, then you should be okay on that end because your hole is obviously bigger than the low end of your tolerance. If your no-go side does not fit, then you should be within your tolerance of your hole. If the no-go side does fit, then you're out of tolerance and your part is scrap. So one more thing, you can see that I still have quite a few of these that are still wrapped up in the paper that they come wrapped in to prevent rust. I just unwrap them as I need them because they're a bit of a pain to unwrap. Sometimes you can actually unpeel them, but most of the time it just starts shredding. So what I generally do is just grab my fingernail, tear down that way, and you can get it unwrapped pretty fast. And then I would definitely wipe off the anti-rust goo with the solvent of your choice before you put it back in the box. This set is actually an import set, and I'm not going to spend hundreds or thousands of dollars getting a really high quality set because I don't use them all that often. The other thing about import gauge pin sets and import gauge block sets is if they say they conform to the specifications that they should, then they conform. And I've actually measured every single one of these that I've unwrapped, and it does fit the specifications, the -2/10. So I wouldn't be shy about buying an import set. They are a lot cheaper than the American-made sets. especially if you're a home shop and you're not doing this as a business, but you need an accurate way to measure holes. Anyway, I hope this helps, and I'll see you next time.
These are what I am calling simple gauges, uncomplicated but powerful tools with few or no moving parts that define precision. Pin gauges, also known as plug gauges or even go, no-go pins. If we want to know what size a hole is, we test fit pins until we find a pin that fits, that is next to a pin that doesn't fit. We now know for certain that our actual hole size is somewhere between these two pin diameters. Now that's pretty quick, but if we just want to quickly find out if a feature is good or not within spec, we can pull pins at both the low end and the high end of our tolerance and load them into a go, no-go handle. If the go pin fits and the no-go pin does not fit, then we know that we have a good part. Nothing is faster, pass or fail, go or no-go. Some pin handles make use of actual collets, but they're only good for a few pin sizes. These pin handles are actual pin vices with an enormous range, kind of like little chucks. We can see how the three jaws are held parallel to the pin as the collets are closed. This one handle can accommodate any pin in this whole set. The same is true for this handle and set, and this one. Now this might sound like a random fact, but as many as 1 in 10 men are colorblind. And this matters when looking at gauge pin handles because while many of us see the red and green color markings on our go, no-go pin holders, a good number of operators just see this. Find a handle like this one that makes use of an identification groove as well as colored end caps on top of go, no-go markings. This style of handle also makes a terrific pin vise for holding deburr tools and countersinks. This essential machinist tool looks an awful lot like gauge pins, and they're very similar, but they serve a very different purpose. These are thread measuring wires. These pins or wires are precision ground and come in sets of 3. We use them along with a regular set of micrometers to measure the pitch diameters of outside threads. This is a pretty clever feat. We are told which pins to use based on which intrametric thread we're trying to measure. And it's all in this little manual that comes with the thread measuring wires. We follow the instructions, measuring on the outside of the 3 wires and subtracting the listed constant value. And we have our machine thread pitch diameter that we can compare to the nominal pitch value that we might find in our machinery's handbook or elsewhere. No heavy math, no trigonometry, simple. Now if you are cutting threads all day long on a lathe, you need to be looking at a nice set of pitch micrometers. But for the price and simplicity of a set of thread measuring wires, they belong in every machinist box. These are threaded ring gauges, and we can use them to check and see if our outside diameter threads are within tolerance. These gauges have been precision ground at the top and bottom of our thread tolerances to work as go and no-go gauges. If the go threads on and the no-go does not, then we know that our specific thread pitch is correct. We will still want to check our thread major diameter with a set of calipers or micrometers. These threaded ring gauges are checking our pitch and our pitch diameter all in one shot. Go, no-go gauges are fast and reliable. For threaded holes, We can use threaded plug gauges to make sure that all of our internal threaded features are correct. Again, we have a precision ground go side, which should thread in nicely, and a precision ground no-go side, which should not thread in. These gauges are checking our thread pitch, our thread lead, and our pitch diameter all at one time. For a more complete ID thread inspection, we're going to want to check our thread minor diameter as well. That was created with our tap drill, and we can check that using regular gauge pins. Of the hundreds of different inspection tools available to us, gauge blocks are special. Now, they don't appear to do much. They just sit there with no electronics, no gears, no moving parts at all. But this isn't a fault, it's their genius. Designed to be stacked one on top of another with high reliability and precision, they are the final say in accuracy when used to measure our parts or calibrate other inspection tools. Pick a number, any number, and we can create a stack of gauge blocks to that height in increments of just 1 micron for our metric sets or 1/10 of a thou for our inch sets. Placed on a granite surface plate, our gauge blocks can be used as a reference to measure the height of a part or feature with incredible precision. Combined with a drop gauge, our gauge blocks can provide the absolute reference values that we need. Now, we will use gauge blocks along with a little trigonometry to produce perfect angles using sine bars or sine plates. Now, we don't just stack our blocks together. We actually ring them together, like ringing our hands. This creates a strong bond that holds them firmly in place. Now, this is an amazing property of physics that is worth looking up sometime. With the right accessories, they can be used to create precision gauges for inside diameters, ID features as well, saving us the cost and lead times of custom ring gauges for every job. Gauge blocks provide that second opinion, the final verdict, when it comes time to verify all of our other adjustable measurement tools. For easily setting up or inspecting precision angles, we can use angle blocks, one at a time, or we can stack them to create any angle we'd like. I'll often use them in a vise, avoiding the hassle needed to create angled fixturing for quick jobs. And remember, these can be stacked or rotated to create the angles that we need. In the world of physics, a simple machine is a basic mechanical device that changes the direction or magnitude of a force, like a lever, wheel and axle, pulley, inclined plane, wedge, or screw. Simple, yes, with few or no moving parts, but absolutely revolutionary, just like our simple gauges. These gauges quite literally set the standard for all of our other inspection tools.
Vida Kalemi Mastarı. Bu mastarlar universal torna tezgahlarında diş açma işleminde kullanılacak olan vida kalemlerinin iş parçasına dikliğinin ayarlanmasında ve bilenmelerinde kullanılırlar. Bu mastarlar, sadece üçgen vida kalemleri için yapılmış olabildikleri gibi, bazı tiplerinde üçgen vida, trapez vida, kare vida ve hatta matkap uç açısı içinde tek mastar şeklinde yapılmış olabilir. Profil Mastarı. Makine parçalarının fatura birleşme yerlerinde yapılması istenen iç bükey ya da dış bükey kavislerin, profillerin, vida dişi profillerinin uygunluk kontrolünde kullanılır. Bu mastarlar takım halinde üretilir. Her bir mastar plakası üzerinde profilin radyusu ya da vida adımı yazar. Profil mastarı endüstride yarıçap mastarı olarak da adlandırılır.
While many measurement tools are designed for high precision, these gauges are fairly simple, made to provide a quick measurement so you can avoid delays and keep your job on track. It's always good to keep screws organized, but sometimes you need to use one that looks about right but is not identified. You need to find out the screw pitch or threads per inch. This model number 6 screw pitch gauge has 30 leaves ranging from 4 to 42 TPI or threads per inch. The leaves fold out from each end of a rugged steel case and can be locked in place with a light twist of the knob. Here you have a screw that you think is the right size, but you need to be sure because you might ruin your workpiece if you strip a thread with the wrong size screw. Finding the pitch of the screw is simple. Hold a leaf that looks about right up against the screw. Oops, that's too big. Let's try a couple of sizes smaller. Nope, too small. Alright, we'll try the one in between. That's it. The screw has a pitch of 16 TPI. Some screws have metric threads. For that, we have a similar gauge, the 159M, which has 28 leaves to identify threads from 0.5 to 11.5 millimeters. Here, we are using the 159M to verify that our mystery metric screw has a pitch of 2.0 millimeters, just as we expected. It's always good to be right the first time.
Konik Mastar. Makine ve otomotiv sektörlerinde sıklıkla kullanılırlar. Silindirik ya da plaka biçiminde imal edilir. Her iki tür mastar üzerinde de bölüntü çizgileri vardır. Taşlanacak olan deliğe mastar sokulur ve mastar üzerindeki bölüntülerden yararlanılarak istenilen ölçüye göre kontrolleri yapılır. Kalınlık Mastarı. Bu mastarlar çeşitli kalınlıktaki çelik saç ya da tellerden yapılmışlardır. Hassas olarak taşlanmış olan bu mastarlar, makine ve otomotiv sektörlerinde yaygın olarak kullanılırlar. Metrik ve inç ölçü sistemlerinde üretilir. Endüstride bu tür mastarlara sentil de denilmektedir.
We're going to measure the amount of movement on this gear right here. It's actually fifth gear. But if you look at this, you will see that it has a little bit of wiggle back and forth. And that clearance is way down in here. So we can see that a little bit better now that I've zoomed in. Right down in there. And we can see that movement. The feeler gauge is going to go right down in here like this, and it's going to slide down in between those two components. So I'm going to use the feeler gauge and I'm going to slide it back and forth, and I'm looking for that exact feel. And I'm going to check the size of this. And the size of this is an 11/1000th of an inch. So this was an 11/1000th of an inch. So the next step would be to try a 12/1000th of an inch and see if that enters as well. So there's my 12, and we'll go ahead and see if that can fit in there as well. And that one goes in as well. So just keep increasing the size of your feeler gauge until you find one that doesn't go in. So I would move to a 13 and so forth. So this is third gear, and it has similar back and forth movement. This is called thrust or axial movement. and that can be measured. Once again, we're going to go ahead and start off with a feeler gauge, and we're going to get down, and it has to go down deep where that clearance is going to be measured between those two gears. So there's that gap, and as I move the gear back and forth, you can see the gap being taken up. So that feeler gauge is going to fit right down inside there like this. And it's going to slide in there. And we're going to keep increasing that feeler gauge size until we find the size that doesn't fit in. So that's our go, no go. And this happened to be that 12 thousandths.
Mastarlarla ölçüm yapma. Blok ve prizmatik mastarların kullanımı. Blok ve prizmatik mastarlar istenilen ölçünün elde edilebilmesi için birlikte kullanılırlar. Bu mastarların kullanımında doğru ölçüyü uygulamak ve mastarlara zarar vermemek için aşağıdaki işlem adımları uygulanır. Gereken boyutu oluşturmak için birleştirilecek mastar blokları seçilir. Mümkün olan en az sayıda blok kullanılır. Mümkün olduğunda kalın kalibrasyon seti tercih edilir. Mastar setleri uygun bir temizleme maddesi ile temizlenir. Ölçüm yüzleri optik düzlem kullanarak aşağıdaki gibi kontrol edilir. Mastar setlerinin yüzeyleri hafifçe birbirlerinin üzerine yerleştirilir. Yerleştirme yapılırken blok boyutlarına göre 3 yöntem kullanılır. Birinci kalın mastarların yapıştırılması. Blok mastarları ölçme yüzeylerinin ortasından birbiriyle 90 derece açı yapacak şekilde üst üste konumlandırın. Blok mastarlara az bir kuvvet uygulayıp birbiri üzerinde döndürün. Blok mastarları kaydırırken birbirine yapışmasını da hissedeceksiniz. Ölçme yüzeylerini birbiriyle hizalı hale getirin. İkinci kalın mastarın ince mastara yapıştırılması. İnce mastarın bir tarafını kalın mastarın yüzeyine bindirin. Daha sonra diğer ince mastarı, önce yapıştırılan ince mastara yapıştırın. Üçüncü ince mastarların yapıştırılması. İnce mastarın eğilmesini önlemek için önce ince mastarı kalın mastara yapıştırın. Diğer ince mastarı önce yapıştırılan ince mastara yapıştırın. Son olarak kalın mastarı istiften ayırın.
Hello, I'm Jim Salisbury with Mitutoyo America Corporation, and welcome to the Metrology Training Lab. In this episode, we want to discuss the truly amazing gauge block and talk about their use and a little bit about their calibration. I have to admit, I'm a bit awestruck with the gauge block. These simple little blocks are something special. Each one with their flat and parallel surfaces, and with an accuracy of just a few millionths of an inch. We've used gauge blocks in previous episodes of the Metrology Training Lab, but in this episode, we get to understand them better and appreciate their role as a premier measurement standard. Gauge blocks come in sets like these, and you can use these sets to build any length you need. And when done properly, those lengths are more accurate than pretty much anything else. What's even more amazing is that gauge blocks were invented over 100 years ago, and they haven't changed much in that time. They have quietly played an important role supporting all the incredible technologies that have been developed since the early 1900s. That's pretty cool. Gauge blocks were invented in Sweden by C.E. Johansson. He didn't invent the idea of length standards, but he patented the idea of a set of blocks that can be used to build various lengths. And he was an incredible machinist, and his company was able to produce gauge blocks to tight tolerances that allowed so many others to achieve new levels of accuracy in manufacturing. Some people will refer to gauge blocks as Joe blocks in reference to Johansson. Johansson was also a pioneer in precision engineering, and the standard reference temperature of 68 degrees Fahrenheit or 20 degrees C comes in part because he needed everybody to pick a common temperature. And when the top scientists around the world asked, he recommended 68 degrees Fahrenheit because that worked well for him. We have here an actual set of Johansson blocks that one of my colleagues at Mid-Toya America collected. You can see the Johansson name and Sweden marked on the gauge blocks. The sets we sell today don't look much different. Modern gauge block sets basically follow his 100-year-old patent. During World War I, the US government became worried about the supply of gauge blocks to the United States from Sweden. Along came a Mr. W.E. Hoke, who developed his own way to make gauge blocks around 1917. He made them round with a hole in the middle to make them easier for him to lap flat. The square gauge block with the hole in the middle was derived from Hoke's design. And still today, you can buy gauge blocks in either Johansson's rectangular design or in Hoke's square design. Rectangular blocks are much more common, but some people like the square blocks. In other episodes of the Metrology Training Lab, you will see us picking either rectangular or square blocks for various tasks. For the interested viewer, Mitutoyo has published a little book on the history of gauge blocks. You can download that for free from our on-demand educational resources on our website. Modern gauge blocks come rectangular or square in inch or millimeter sizes. The typical set includes lengths up to 4 inches, but you can get long block sets up to 20 inches. And you can special order gauge blocks up to 40 inches or 1 meter long. The most common material for gauge blocks is steel, mostly because the price is quite attractive. Other standard materials include carbide and ceramics. One of the big advantages of ceramic gauge blocks is that they don't rust. However, if you take care of steel blocks, such as wearing gloves when you handle them and putting light oil on them when they're stored, they can last years, even decades, depending on how you're using them. For this episode, however, I'm going to mostly use ceramic blocks. The real reason is that these lights here are quite hot, and my hands sweat in these gloves. And getting sweat all over steel gauge blocks is not good practice. Now I could tell you some more advantages of ceramic gauge blocks, but I don't want to sound like a salesman, and that's not the purpose of this episode. Gauge blocks are sold by grades. The grades define tolerances for the flatness and parallelism of the faces, as well as the tolerance for the size that's marked on the blocks. The grades apply whether the blocks are ceramic or steel, and whether they're rectangular or square. For example, these three 1-inch gauge blocks, if they're all grade 0, according to the tolerances in the standard, it would be plus or minus 6 millionths of an inch. If this gauge block, or all three of these gauge blocks, have been properly calibrated and found to be in tolerance, then I would know that the length is somewhere between the minus 6 millionths and the plus 6 millionths of an inch. I told you these things were accurate. If this was instead, say, a grade AS2 gauge block, the tolerance should go from 6 millionths of an inch up to 24 millionths of an inch. Gauge block grades are defined in national and international standards. In the US, we use the American National Standard for Gauge Blocks, ASME B89.1.9. You can also find the tolerance table in the Mitutoyo catalog. All manufacturers of gauge blocks sell them in grades in accordance to the standards. You should select gauge blocks based on your accuracy needs. In a calibration lab, grade 0 gauge blocks are quite common. So, that's a brief introduction to gauge blocks. How do we use them? Gauge block faces are very flat and very smooth. The reason for this is that allows gauge blocks to ring together. Without using any adhesive, gauge blocks can be brought together and the flat, smooth surfaces will adhere to each other without causing any damage. When done properly, the gap between the two gauge blocks is somewhere around 1 millionth of an inch. And when you're done, they can be broken apart and reused over and over. And any flat or smooth surface will ring together. Steel to steel, ceramic to ceramic, even an optical flat, such as shown here. I've rung together 3 different gauge blocks: rectangular, steel, ceramic, and an optical flat. All 4 of those blocks are rung together nice and tight. That's pretty neat. The idea behind Johansson's original patent was the particular sizes in a set of gauge blocks. They allow you to build an accurate stack of gauge blocks to create any length you need. So let's walk through the ringing process. When you ring blocks, you apply quite a bit of force. To avoid scratching your blocks, it's important they are clean. It's important, particularly for steel blocks, to also make sure there's no raised edge or burr or some sort of ding. First, I'll use some denatured alcohol to clean the block. And then I'll use this Mitutoyo Cerastone to remove any burrs. This is sometimes called conditioning the block. We're not changing the length of the block, we're just removing any high spots, particularly on the edges. I can use a small Cerastone like this, using a push-pull technique, or I can use a large one like this, and some people like to go in a figure-8 pattern. And no, you don't have to buy a Mitutoyo Cerastone, but they do work well. Some people recommend using a small granite surface plate. And it's hard to say how often you need to condition your blocks. It really depends on how you're using them. If you were to very lightly slide a gauge block across a surface plate, you may feel it catch or hear kind of a scratchy sound. that indicates a raised spot. In those cases, you should do the conditioning. I'm also not going to pretend to understand the physics on why ringing works. I'm an engineer. I just need to know that it works and how to do it. In fact, it seems to be a bit debated as to why it really works. We'll leave that for the interested viewer. What is important to know is that ringing works best with a very, very slight amount of light oil or grease on the gauge block faces. We really don't use anything special in our lab for ringing. We have these 20-year-old stamp pads lying around that have some WD-40 sprayed on them. Yes, WD-40. And I can only imagine the comments that will be posted on our use of WD-40. All you need to do is dab the gauge block in it and then wipe it off on a dry cloth. We don't use any solvent here because we don't want to remove the oil. We want just a little bit left on it. Now I'm going to ring these two blocks together. And you do have to apply quite a bit of force when you're sliding one block against the other. So I'm going to set these two up here, and I'm going to try to slide this block against this block as so. This is the kind of slide technique. Another technique is kind of the push and slide technique, where you come from a side, you go like this, and then you rotate the block as you're pushing. I'm not doing it now, I'm just trying to demonstrate how it's done. On the square blocks, you can typically use a push and twist technique. In fact, it looks like I just accidentally rung those two together. All right, so back to these two blocks here. I'm going to push on this while I'm sliding across here, and you can see my thumb turn a little bit white as I do that. And if I did it right, those two blocks are now rung together pretty well. When you're all done using the rung gauge blocks, you can just slide them back apart like this. If you leave the blocks rung together for, say, several days or more, it can become very hard to take them apart. So don't leave them rung for too long. Ringing requires handling the gauge blocks, which may warm them up a bit. So once they're rung, you can clean the outside surfaces and then let them sit for a little while to cool back to the ambient temperature. How long to sit depends on how much you handle them and what your accuracy needs are. If you want to see how well you can ring, a fun and easy test is to ring two blocks together that add up to the value of a third. Say this 450 and 550 block, which add up to 1 inch, and we compare it to a 1 inch block. So we ring these two blocks together, and then using something like a high accuracy detector like this mu checker, I can then compare the rung block stack to the single block. Now this test is not super accurate, but it should be good enough to see if your ringing skills are good enough to, say, calibrate a micrometer. Our last topic on gauge blocks is their calibration. In our calibration lab here at Mitutoyo America, we use really cool automated gauge block comparators. But we have a manual version here in the metrology training lab. So let's head over there and I'll discuss some important topics on calibration. Gauge blocks are usually calibrated using a comparison method. This is the master block and this is the customer block to be calibrated. We set the comparator using the master block, and then measure the customer block. In accordance to B89.1.9, the length tolerance for gauge blocks applies across the entire surface of the gauge block, not just at that gauge point. And the standard discusses the importance of checking the size in addition to the gauge point at all four corners. This fixture here moves the gauge block around such that we can measure the four corners quickly and easily. In order to state conformance to grade, in accordance to the ASME B89.19 standard, all 5 of these points must be in tolerance. Gauge block calibration practice in the United States is sometimes a bit sloppy. To save calibration costs, some people have been convinced to go with a single point calibration, where the corners are not checked at all. The only time that's acceptable is when you're only using the gauge block at that exact measurement point. And I think that's pretty rare. Please be careful with exposing yourself to calibration risks just to save a few dollars. If you just need a cert to show some auditor, well, that's your business. But if you really care about quality, do the calibration right. I hope you learned a few things about gauge blocks. If you have questions or want to see something else on gauge blocks, please post your comments. Thank you. I'm Jim Salisbury, and I'll see you next time from the Metrology Training Lab.